And we're live. Oh, yeah. I totally got my own talk show. I got my own microphone and everything. It's great. I really hope the microphone's working the way that I want it to. I really do. I didn't actually test to make sure that the microphone was working. Can you? I have one person in the chat. I really hope that you can hear me. Can you hear me in the microphone? Actually, no, I got like 2 people in the chat now, but whatever. Can you hear me out there in the digital world through this microphone? I really hope I don't have to redo the stream. Well, we'll see what happens. I'm going to keep using the microphone. I'm really hoping it's working. I did plug it in beforehand. And the microphone default is the thing that I'm holding. So we'll see what happens. Okay. Welcome. Today we are going to be playing Hi-Ho Cherry-O. I don't know if any of you have ever heard of Hi-Ho Cherry-O. You said you never played it before, but you never heard of it at all. That's fine. That's totally fine. It's a kid's game. It is a kid's game that is designed to kind of teach kids, oh, it's okay to lose and blah, 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 blah. But more importantly, the basics of counting, the very basics of counting. The way that this game works is that you can have you could have 2 to 4 players, and you start with 10 cherries on your tree, and then you spin the spinner. Now, let me zoom out just a little bit. Zoom out just a little bit. There we go. Now, on this spinner, there are 7 spots. And obviously, this is what comes into play with random selection. If I were to spin it, obviously, that is a random selection that happens. Now, there are 4 spots on here with a 1, a 2, a 3, and a 4 set of cherries. If you land on that set of cherries randomly, then you are to take that many cherries off the tree and put them into your bucket. If by some chance you land on the bird or the dog, then 2 cherries come out of your bucket and go back up on the tree. If you land on this thing right here, which is what I landed on, then your whole bucket spills and everything goes back up on the tree. You only win the game if you can get 10 cherries in your bucket. Only 10 cherries. So for example, if you were down to like maybe 1 cherry and you landed on a 3, perfect, you're fine. You got 10 cherries. Put them in the bucket. It's a weird game. It's called Hi-Ho Cherry-O. And then once you get all 10 cherries in the bucket, you get to exclaim Hi-Ho Cherry-O. So the question then becomes, or my question becomes, how many spins will it take in order to win the game? I'm just going to do yellow versus green right here just to see what happens. Oh, landed on the dog. Oh, spilled your bucket. Oh, we got a 1 for yellow. We got a 1 for green. Oh, spilled your bucket, yellow. Sucks to be you. Oh, I can't get the cherry out of the bucket. All right, there we go. Cool. Spilled your bucket, green. I'm going to ask you guys the following question while I keep playing this game. Theoretically, how long can this game last for? Yeah, theoretically it can, which is the weirdest thing, right? Like, there is some weird scenario out there where you could like end up playing this game for days and days, and there it is. There's the bucket for green. Oh man. So like I just did all those spins. I haven't even counted how many spins there were, which by the way, we will when we actually play. Unfortunately, I can't let you play with the actual game, but we are going to have to keep track of how many spins it takes in order to win the game. I played this yesterday with ProbStat. Oops, spilled the bucket. Played this yesterday with ProbStat using a random simulation that we did on the calculator, which I'm going to show you how to do. And some people, they won it in like 4 spins. 4 spins, they won the game. Good for them. Spilled the bucket. The record yesterday, 38 spins. 38. Honestly, sometimes that can happen. Sometimes these games can last like moments. There we go. Sometimes these games can last minutes. Okay, here we go. Now we're getting somewhere. That's the dog. Come on. Come on, green. You're going to win this game, aren't you? Yes, green. You're almost there. Yellow. Oh, sorry, yellow. Still got nothing. Green. Green is almost there. Here we go. Yellow. Oh, yellow. 1, 2, 3, 4. Come on, green. Yes. Green wins the game. And then gets to exclaim, hi-ho, Cheerio. It's a fun game. It's for ages 3 to 6, clearly. But the point of it is this. Last week, I introduced to you the basics of randomness. We talked about randomness, random.org, random number tables, the whole shebang. And now today, we are going to do a deep dive into random simulation. Last week, we did a basic random simulation where we set something up. We set up a problem where we did random number assignment and then did a whole stopping point response variable thing to the whole. It was fantastic. We're going to do that to this game. We're absolutely going to do that to this game. But in order to set up the random simulation for this game, I need to show you how to use the random number function on your graphing calculator. You got a Chromebook? Okay, break out the calculator, then that'll still work. If you break out the calculator on the Chromebook, that'll do exactly what I want. Now here's the interesting thing. On the Chromebook, every time you open the calculator on the Chromebook, does it say RAM cleared? Like on the calculator screen? Yeah, no, I gotcha. No, but it's supposed to do that. It's supposed to say RAM cleared. Now, what's really nice about the graphing calculators, the physical ones that we're holding, is that they don't always clear the RAM every single time. Now, mine does. If I kind of zoom in right here a little bit, if I go second plus sign 712, then clearly it's RAM cleared. Oh, happy day. Into my computer? I'm trying to think. What's a better place you could do that? If you... No, I gotcha. If you sat in that desk, you could plug it into the laptop up front. Yeah. Are you able to use it while it's charging? Yeah. Cool. All right. Yeah. And you'll be fine there. Each desk is still 6 feet away from each other, So, what I want to show you in the calculators is this. First, after you have cleared that RAM. Oh, there he is. It's all good. I just heard it. It's all good. Yeah. There you go. If you hit math, now math on your calculators is in the first column. If you go in the first column going down, you hit math, you should come to this screen. Now on this screen, if you tab over to PRB, PRB is what I'm going to be focused on today. Should still work. If you go there, does it still have these options? Good. Go to RAND, just the first one, RAND. Now, what's going to happen is that RAND is supposed to give you a random decimal between 0 and 1. Now, I don't know if you reset your calculator. That's perfectly fine if you didn't. Okay, that's fine. We'll see what happens. Now, here's the thing. The calculators on the Chromebooks automatically reset. So hers is reset. I reset mine as well. Okay? When you get to RAND, just hit enter like maybe 3 or 4 times. Okay? And you do the same thing on the Chromebook as well. Now you get you got decimals, right? These decimals look random. It's a random number between 0 and 1. Is that fair? Watch my calculator. What do you notice? Same exact decimals. That doesn't seem random to me. Last week I talked about pseudo-random. That's exactly what this is. It's pseudo-random. It's completely pseudo-random. What the heck? There has to be a better way of going about it. The decimals that I get are exactly the same as you. Well, I want to show you very briefly how you can seed your calculator. And we're going to need this for hi-ho Cheerio. We need to seed our calculator because if we are all going to be running a random simulation in a little bit, we need to not get the same answers. So we need to seed our calculator. Now, the handheld calculators Once you seed them, they'll stay seated. And turn them off, turn them on, they'll stay seated. The only time it'll go back to this is if you reset it. The Chromebook calculators, every time you open them, they reset. So don't close it out and don't reopen. Just seed it once and it should be fine. But here's what I'm going to do. I'm going to pick a number. You don't pick my number. Pick a different number. I picked today's date. You pick a different number. Pick your birthday. Pick your favorite number. It doesn't matter. Pick some kind of number for us to seed our calculator. Then, in the no, absolutely not. Nope. I just picked today's date. You pick something different. That's fine. It's perfectly fine. Now, in the bottom left of the calculator, in the bottom left, there's this button called STO. STO is store. We are going to store this number somewhere. So I'm just going to hit that button once, and then on my screen, a little arrow, meaning it's about to store it somewhere. And where I'm going to store it is in that word, RAND, R-A-N-D. I'm going to store it in RAND. So what I'm going to do when I get here, I'm going to hit math. I'm going to go over to probability, and I'm just going to pick the first one, RAND. If you hit enter, it just should say the number over again. But it's seeded. I have seeded my calculator. I have successfully seeded, which means now that when the three of us do that random function one more time, we should get completely different numbers. Completely different, which I want to do that one more time. So go back to RAND. Math, PRB, RAND. I'm just going to hit it like 2 or 3 times. Yeah, you should get completely different numbers. Now, that's fine. You don't have to do anything else to the calculator. You don't have to seed it anymore. You don't have to change any of the settings. You don't have to do anything like that because since it is seeded, and as long as it's not reset, we're good. And now when we run the simulation, we should get different answers, which is exactly what we need. We needed different answers because that's what randomness is all about. The number that I get should not match exactly the numbers that you get. So we want to run this random simulation with Hi-Ho Cheerio. So what I'm going to do is I'm going to temporarily put my calculator aside. And ladies and gentlemen, or lady and gentlemen, whatever. I say ladies and gentlemen all the time, but now it's just 2 of you. Whatever. I don't care. I'm going to need those notebooks out and open. For those of you in the virtual land, you can do the same thing. For those of you in the chat, I see there's 2 people in the chat right now. I can actually see the chat. Here's a little inception for you. I'm looking at the chat right now on my phone. And you can see on the screen right there, it's doing a little inception, which is awesome. But anyway, I digress. Turn that. There we go. Good. But what I want to do is I want to run this random simulation. Now, when I do notes, and you already know what the deal is. You've had me before, but you haven't had me before for notes. We started this last week a little bit. But notes, as I've said, I'm going to keep reminding you, at least for the first few weeks, notes are important for this class. There's not going to be a textbook that I'm going to be assigning you. So the information that I'm going to get you are going to be from your notes. The notes are going to be available. I'm going to have copies, hard copies of the notes, as always. But of course, the notes you could always get from the live stream. It's just probably a little bit more difficult to get them from the live stream if you're kind of searching through all this stuff. But here we go. Today is the 15th. Payday for most people. Oh, yeah, halfway through the month. Some people only get paid twice a month. Some people get paid every other week, but some people get paid twice a month. Middle of the month, end of the month. Yeah. We're going to do a simulation of Hi-Ho Cheerio. A lot of the kids' games that they have back in the day, they're like just like completely randomized and like a game that like there's no real skill to. Like, have you ever played Candyland? Like, there's no skill to that. There's no skill to Candyland whatsoever. You know, Hi-Ho Cheerio, there's no skill to Hi-Ho Cheerio. It's just spin it and see what happens. You know, my son has this game. It's called Naked Mole Rats in Space. Yeah. Naked mole rats and spades. And that game actually does have a little bit of skill because you and whoever else is on your team are trying to walk through a space station, collecting items and avoiding snakes. And you either go up ladders or you could fall down tubes. And the goal of the game is to get your entire team and those items to the escape pod in the middle of the board.
It's like a physical game.
Yeah. No, it's a physical game, yeah. And meanwhile, these snakes are coming around. If the snake bites you, you got to go back to the beginning. But if you get bit a second time, game over. And if it's game over for you, everybody loses. Everybody. The game is either everybody wins or everybody loses. It's a fun game. It's like Pandemic. You ever play Pandemic? We're living it. Anyway, no, it's actually a real game and it's fun. Anyway, let's get some information here. First, in order to do this random simulation, I'm going to have you guys do rand int 1 to 7. I'll show you that in the calculator in a little bit. But we are going to be using the random int function. Last week, we used a random number table, which is perfectly acceptable, but I want to use the graphing calculator this time around. And since we have seeded our calculator, I can't even say the word properly, since we have seeded our calculator, we should be getting different randomized results, and that should be fine. Now, in order to do this simulation, we got to start with number assignment. Last week, I said the first step was we have to assign numbers. So we're going to get a random integer between 1 and 7. We are going to let 1, 2, 3, and 4 be that number of cherries. So if we do rand int 1, 7 and then hit enter, and I'm going to show you how to do this. If you get 1, 2, 3, or 4, that's going to be that number of cherries coming off of the tree and ending up in your bucket. That was funny. It was comedic timing and gold. Anyway, we're going to let 5 and 6 be the bird/dog, losing 2 cherries. In years past, I would be able to be like, hey guys, let's break up into groups and let's all play Hi-Ho Cherry-O against each other. I can't do that this year. I can't let people be in close quarters for a long time, especially when, people in neighboring school districts are testing positive. We are going to let 7.
So what happened with them? Did they get closed down?
No, they haven't gotten closed down yet. They're trying to isolate the problem. So what they did was they isolated the kid that tested positive. They alerted everybody within that cohort to be on the lookout for symptoms and signs and stuff like that, and to encourage them to get tested if need be as well. But it's just that cohort. You guys are cohort 2. So if there was a Barnegat cohort 2 student that tested positive, then everybody in cohort 2 would be notified to be like, hey, just so you know. We'll see what happens.
Not going to get shut down unless it keeps adding up.
I believe so.
Yeah.
I believe so.
It's a certain amount of people.
There's a minimum number.
There is?
I think so. I don't know what it is, but I believe there is.
I was talking to Boy about it too. He said there has to be a certain amount of number for them to do something.
Oh, yeah. So if you get a 7, you spill the bucket, you go back to 0. Now, this is the number assignment. When it came to the random number table, we had to assign numbers to be a certain result. I think I froze. There we go. Boom, there we go. We had to assign numbers to get a certain result. This is exactly what we've done, and we're fine. This is a number assignment. Now, last week, I wrote down those bullet points for you. I said the next thing we had to do is we had to identify a stopping point. We need to know, okay, how long will the trial last? The trial stops when you have 10 cherries. Literally, if you get to a point where you have 10 cherries, done. The trial is over, and we can record the response variable. Which leads me to the original question that I had for you guys. The original question that I have for you guys, how many spins should it take to win the game? How many spins should it take to win the game? Now, it could be 4, it could be 38. Yesterday, again, somebody had 38 spins. It happens. But, I know, right? The response variable is how many spins to win. How many spins to win. This is the simulation right here. Everything that is on the board right now, this is all that we need in order to run this simulation. We seeded our calculators, so we have randint 1,7. We have 1, 2, 3, and 4 being that number of cherries being taken off the tree and put in our bucket. 5 and 6, we lose 2 cherries. 7, the bucket goes back to 0. The trial will end when we get 10 cherries, and the response variable will be how many spins did we need to win. So, I want to walk you through this, and then I'm going to have you guys run a random simulation. I'm going to walk you through one trial, just one, and then I'm going to have you guys do different trials. Let's actually do this. So this is my first trial, T1. This is my T1. Now, here's the thing. Don't write down my trial. Don't write down my trial. Write down your trials when you do them. But let me walk you through what you need to do. Now, I've already seeded my calculator clearly. Well, here's the thing. I want you to watch me do it once. Watch me do it, and then I'm going to have you guys do some trials. Okay? Let me reconnect the chat there. There we go. So I'm going to hit math. I'm going to tab over to probability. I'm going to go to randint. Randint is what we need. 1,7. Now, if I do this, I've properly seeded it. I'm going to get random numbers. Here's my first spin. Boom. First spin, I got 3 cherries. Hey, here's the thing. What if my first spin was like a 7? What do I write down? Yeah, I write down a 0 because technically I started with 0, and after one spin, I still had 0. But here, I got 3. Spin, I lose 2. Mind you, I'm not recording the fact that I lost 2. I'm just recording the fact that now I'm down to 1 cherry. Trial 1. Just trial 1. Yeah. You do trial 1, game 1, whatever you want to call it. You know, boom. I lost 2. Down to 0. I got 4. 4 cherries. Come on. 5. I'm down to 2. 5. I'm down to 0. It could yo-yo back and forth like this. It legitimately can yo-yo back and forth like this.
You're just taking this for one
4.
bucket, right?
Yeah, for one person.
Yeah.
5. I'm down to 2. 1. I'm up to 3. 5. I'm down to 1. 3. I'm up to 4. 1. I'm up to 5. 4. I'm up to 9. Yeah. Trial over. Now, keep in mind, that's just the trial. That's just one trial. I met the stopping point. The stopping point is when I had 10 cherries. But the response variable is how many spins it took. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Took me 14 spins. So 14 is the number that I'm going to record as a response variable, and that's one trial. Now, here's what we're going to do. Over here, I'm going to run 10 total trials for myself. I'm going to run 10, and I want each of you to run 10 as well. Each of us are going to do 10 games. Some of these games might last, 4 spins. Some of these games might last 14 spins. But once you get the hang of it, they're going to fly by. So you have the calculator on the Chromebook. You have the calculator in front of you charging, but it's still working?
Yeah.
Good.
Yeah, it's all good.
Then let's do this. You guys do your 10 trials. I'll do my 10 trials, and then I'm going to show you what we're going to do with those numbers. So let's go. And For every trial that you do, you don't have to reset the calculator. Don't reset it. Don't reseat it.
So to start this off,
Mhm.
I'm gonna do math,
Yep.
prob,
Yep.
rand,
Rand int. Yes. And then 1,7.
But that's in parentheses.
Yours says lower upper. Yep, 1 and 7. And then it says n, right? Leave that blank. And then it says the word paste. Yeah. The beauty is, once you kind of do that,
This is lower upper too.
do 1 and 7, and then hit paste. The beauty of it is you don't have to keep going back into that function. You just have to keep hitting enter. As long as you keep hitting enter, it'll do the same exact function over and over again.
So just like that, right?
Let's see what happened. Yep.
Enter.
Yep. Boom. You lost 2, so you got 0. But you got to record that as a spin. So you write the 0, and then you do your next spin.
So we're starting off at 0.
Yes, absolutely. You got to get up to 10 cherries in your bucket.
So the rules are, so how does this work? Since I got a 6, right?
Mhm.
What do I do?
You write a 0 down.
Why? Because I got 0 cherries.
Yep. After 1 spin, you still have 0 cherries. Now spin it a second time. What do you get? 7. You still have 0.
Really?
Yep.
Why?
Because 7 is spilling your bucket.
Okay. So what's 6?
Either the bird or the dog. Losing 2, which is still at 0. Hit enter again.
0.
Okay. Keep going.
0.
Yep, that happens. Keep going.
3.
Now you got 3 cherries. Because 1, 2, 3, and 4 represent getting that number of cherries.
4.
Yep, now you got 7.
No, my bucket's full.
That happens.
No, I have 0, right?
Yes, now you get back to 0. Now, yeah, you got the same exact number that I did. Yes, I know. Actually, I have a reason why that is, but I'm going to share that with you later. So you got 14, and then you got all 10 cherries? New game.
0.
I got to run my trials, too.
0.
No, dude, I'm not even kidding. Remember what I said. Sometimes these games could last forever. But I got to run my trials too, so hold on.
6, 7, 0. This is great. 0.
Oh, you got 5 spins? Okay.
0.
3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Hey, check this out. I got 14 spins again. That's actually pretty crazy. Let's try it again. Boom. Oop, not 0. Sorry, it's there we go.
Finally.
2, 3, 4.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
Nice. Here, tell you what. I'll be a little bit lenient. Instead of doing 10 trials, let's all do 5 trials. Just do 5 games. Yeah, we'll do 5 games. That should be sufficient for what I want to show. So just 5 games.
I was about to say, we take a long time.
I know.
So now they'll just reset that.
No, don't reset anything. Just keep hitting enter.
Just start again.
Start again. Just hit enter and start again. Yep.
We start off at 0, you said, right?
Yes.
We write down 0 first.
Mm-hmm. Well, actually, no. Don't write anything before you start. Like if you just hit enter and then write down that first number. Like look what I've done up here. Like this
I'll put
game.
0, and then I'll put the first number.
Yeah, don't do that. Don't do that. Like what I did up here is the first number I wrote down was 3 because after 1 spin, I got the 3 cherries.
Mm-hmm.
After 1 spin right here, I got like a 7, so I got 0.
Good.
Yeah.
This is why I got my first spin was a 2.
Yep,
My
so you start
second spin
2.
was a 7, so I write down a 0, not a 7.
Correct. Because you spilled your bucket, you went down to nothing. right, I'll get your numbers in one moment.
So I got a 3.
Yep.
And then equal to 4 because I got a 1 before that.
Yep.
And then the spin after that, I got a 6. What would I add that?
Minus 2.
Oh, minus 2.
Because the bird or the dog loses you 2 cherries.
So what would be the bird or the dog?
5 and a 6.
5 and 6.
Yep. Like I said, I'll collect your data in a minute. I'm going to get his data in a little bit as well. I got, like you said, talk about 14. I got 14 the first 3 tries.
I got 1, so then the rest of the time I got low numbers.
And that happens, you know.
Lucky.
Like I said, record yesterday was 38.
It doesn't sound fun. I'm getting close to it.
In years past, I would have like when it was like a normal year, I would have like a class full of kids, and I have 2 kids set up at the front, and they'd literally be playing this game, and everyone just kind of be like cheering or yelling or jeering with every spin. It was pretty funny. I don't know.
I got 30 the first time and 12 the second time.
Exactly. Oh goodness. I'm gonna put my numbers in right here. Now, what I'm doing here, you guys don't have to worry about how I'm doing this right now. I'm going to teach you this another time, but I wanted to show you something with your numbers. What 5 numbers did you get?
14, 6, 8, 4, 5.
So again, the numbers that you just gave me were your response variables, the result of the trial. And the numbers that he's going to give me are the same thing. And what we're going to do is we're going to average these things together. It's going to be phenomenal. Aha. What trial are you on? Nice. Oh, good. You got it.
Just taking,
No, you just got 10.
oh, I did?
Yeah.
Oh, yeah. I'm gonna
Yeah, once you get to 10, you're good, dude. Once you
I don't know why.
you got to 10 earlier. You just did double the game. Yeah. Actually, you know what you can do? Can I borrow that? Check this out. You can consider that trial 4. Right?
That's fair enough.
Yeah, because then you got like what, 1, 2, 3, 4, 5, 6, 7, 8, 9 here. And then you got 1, 2, 3, 4, 5, 6, 7 there.
That's fair, yeah.
Yeah, there you go. So one more trial. Mhm. Mhm. So you got to do one more. There you go. So you got to get one more. Now, the interesting thing about, but by the way, the only reason why that worked is because after you got 10, you went down to 0. Yeah. So the interesting thing about this is like, you think about like mathematics in the real world, right? There are 2 big AP classes in high school, AP statistics and AP calculus. And students ask me, because I'm the AP statistics teacher, and they ask me, Mr. Markey, what should I take? Should I take calculus or should I take statistics? And my first question is, well, what are you going to do with your life? No, honestly, what are you going to do with your life? What are you going to go to college for? What are you going to do after high school? And the thing is, if the answer is, I'm going to be an engineer, or I'm going to study higher level mathematics, or something along those lines, then the answer is calculus. Everything else, statistics. Everything else. Because the basic simulation that I just described to you, the basic simulation that we just ran right here. Now, this is very basic. It's very rudimentary. It's very entry-level stuff. But some of the more advanced random simulations, people at companies pay big money for. Companies hire statisticians in order to run random simulations to see whether or not a decision is going to work. Like, okay, we're about to launch this particular product. We want to see how it'll perform in the marketplace. Let's run a simulation just to see what will happen or what could happen, and then see if it's worth our risk. That is the job of a statistician. Somebody who has gone to school and studied the different things that you can do with statistics and the different type of tests and simulations and samples that you can run with statistics. Companies will pay big money for it. Just saying. Yeah, statistics is much more applicable to so many different things in life. Exactly. I have an aunt. I'm sorry, aunt. What do you call she's not really my aunt. It's like I married into the family. You know what I'm saying? Whatever. My wife's aunt. Cool. She works for Aberdeen Proving Grounds down in Aberdeen, Maryland, and she worked as an engineer. And this is the kind of stuff. It's a military base, and she would run these statistical analyses on different things that they gave her, and again, people who have that kind of knowledge and have that kind of skill, big money. So I need your 5 numbers here.
30.
Yeah.
12.
9. 7.
17.
17. Nice. Okay. Now, we ran 15 trials. You guys run 5 each. I ran 5. We got 15 trials. Now, like I said, don't worry about where I'm putting this in the calculator. Don't worry about that. That's not the point of this. Don't worry about how I got here. Don't worry about that. But I am going to run this. These numbers are what we call your summary statistics. This is your average. All 15 trials that we ran, this was our average. Remember how I got 14, 14, 14, and you got 14 your first time out, and then you got a bunch of low numbers?
Wait, you got 14 3 times.
Yes, I did. Yeah. That's our average. Now, an average, that's just an average of 15 trials. Obviously, the more trials that we ran, the closer that we'd come to the actual true number. But that's just our average. Have you guys ever heard of standard deviation?
No.
That's fine. Well, you will in this class. I'm going to teach you what it is in the future.
It sounds like something has to do with a plane.
Nope. Here's the basic definition of standard deviation. First of all, this number right here is your standard deviation. What it means is this. And this is not the lesson for today. I just kind of wanted to talk about this real quick. The average is around, 11 point something? The average is around 11 point something. Some numbers deviate in the positive direction. Some numbers, that was +3 from the average. That was +3 from the average. +3. That was -7 from the average. That was +1 from the average. That was +3. That was -5 from the average. Every number deviates by either a positive number, a negative number, or it just nails the average right on it.
What was the average, 11 point something?
11 point something. Yeah. The idea is that standard deviation is very similar to average deviation. Average deviation. This number deviated by 3. This number deviated by, 7. Now, yes, it's a -7, but you count it as a 7. And the average deviation in this case was about 6.6. The smaller the standard deviation, the more consistent the numbers are. The larger the standard deviation, the more variation that you have, the more varied the numbers are.
So the average deviation is how far the number is away from the actual average?
On average.
On average.
Yeah. It's kind of like an inception thing. How far it is away from the average on average. Yeah.
Sounds weird.
That's kind of what standard deviation is, which we're going to have the calculator do it for us, mind you. We're not going to calculate it by hand. To calculate it by hand is a bit much. In fact, just so you know, I'm not going to have you write this down. But the way that standard deviation is typically calculated is something along the lines of this. Yeah. That is the Greek letter sigma. It means the sum of. Yeah. But again, remember what I said about Prob stat on day 1 compared to AP statistics? This is like the trial version, right? AP statistics, I make them memorize that. I'm not going to have you guys memorize that.
I'm good.
I'm not going to have you memorize that. But here's the beauty of this calculation right here. Check this out. Those numbers should look a lot more familiar. Yeah. Well, yes, those are the numbers I got. Those are the actual numbers. More specifically, minimum just means the smallest number. Maximum means the largest. What is that?
Median.
The median, the middle number. There were 15 data points. Remember doing mean, median, and mode back in middle school?
The
That's that median. Yeah. You know what this number is?
deviation.
Nope. Number of trials. We did 15 trials. These numbers are very consistent from problem to problem. Wherever you have an n equals, that's going to be the number of trials. Median, the middle number. Q1 and Q3, we're getting into those details another time. That's the first quartile and the third quartile.
Which is that like the first trial and the third trial?
Not exactly, not exactly. It's like, think about median. Median is the middle, right?
Yeah.
Median is what we call the 50th percentile. The 50th, the halfway mark.
Yeah.
Q1 is the 25th percentile.
And then that would be the 70, 75?
75th percentile. Yeah. It's like if the median is halfway, then this is 1/4 of the way. And this is 3/4 of the way. Yeah. That's basically what those come down to. But these numbers can be very important moving forward. Especially this number right here. Oh, it's going to be great. It's a what? Oh, that's the average, but that symbol I'm going to write down a little bit later. You'll see what I mean. I'm going to write it down a little bit later. So, ladies and gentlemen, lady and gentlemen, I'm going to keep getting used to that. Let's write down some summary numbers. First of all, because here's the thing. Last week, I talked about how we run a simulation. We have to assign numbers. We have to create a stopping point. We have to identify a response variable. And we have to come up with a suitable conclusion. We need to come up with a suitable conclusion. This is hi-ho, Cheerio results. Now, our, what we call X bar, and that's actually how you read that. It's called X bar. That is our average, or our mean. We ran 15 trials. That's what n equals 15 is. And let me remind you of the question. The question that I had asked was how many spins will it take to win the game? How many spins will it take to win the game? Can I make this shot? Nope, missed terribly. Now here's the thing. Will it take 11 or 12 spins on average every single time for every person in the world? I don't know. Maybe. Could. It could. But we can't be certain. We can't be 100% certain. So I mentioned last week that when we come up with suitable conclusions, we have to be fluffy with our answers. We have to be fluffy. We cannot take a definitive stance on our conclusion. So this is what I'm going to write.
Never.
Say again?
Never.
Never. In statistics, you can never be 100% certain. You can't. Because basically with statistics, like think of it this way, with statistics, you run polls, which are samples, which are just basically guessing as to what might happen. You know what I'm saying?
So you never really actually know until it happens.
Or you run like a billion trials and then hope it works out. Like for example, I could flip a coin, right? I could flip this coin right here. I'm just showing the camera. I could flip this coin. And it's got a 50-50 shot of heads and tails, right? I could run 100 trials, 100 flips of the coin, and I might get 52-48. Am I wrong?
No.
No, I'm not wrong. That's just natural variation, right? If I got 52-48, you're like, well, that could happen. That could totally happen flipping a coin. Yes, it can. I'm not wrong. But I can say, based on my simulation, I got 52% heads. I'm not 100% certain that that's correct, but I'm fairly certain I'm close. Statistics is weird. There's a lot of wiggle room. Check this out. Based on our simulation, of 15 games. Immediately, I'm saying based on our simulation of 15 games. This is based on our simulation. This is not based on any definitive mathematical research. It's just based on our small experiment. There was an average of 11.33 spins to win. There was an average of 11.33 spins to win. It appears, and again, fluffy language. I'm not using definitive language. I have to be fluffy with how I'm doing this. It appears at least 12 spins are needed to win the game. Now again, notice what I'm doing right here. First of all, I said based on our simulation. I'm diverting the blame if we're wrong. I'm diverting the blame by basically saying, hey, this wasn't any like definitive mathematical calculations. This was just based on the simulation that we just did in class. We got an average of 11.33. Now, yes, that's the fact that we got. But now I say it appears. It appears. I'm not saying it is. I'm not saying it will. I'm saying, well, it appears that at least 12, because again, I had to round. You can't do 11 1/3 spins. That's weird. But I could say, rounding up, at least 12 spins, roughly 12. Oh yeah, I just gotta write you a thing here. It appears that 12 spins will be needed to get this thing done. I'm going to write down some definitions while you're gone, but I'm just checking the time. You'll be very easy to catch up. Sorry, I'm trying to speak and write at the same time, and it wasn't working. Like I can't even chew gum. There's actually a phrasing that we're going to be using in the future. There's evidence to suggest. Evidence to suggest is like the bread and butter of any statistics student. Evidence to suggest is like, it's so not taking a stance on something. It's not saying, yes, this will happen. No. There's evidence suggests that this is what is happening. But if I'm wrong, I got that out. Let me give you an example. Last year, do I still have it? I don't think I do. Where did I put it? Last year I had, there it is. Got it. Last year I had this, and I used this in a class, in an AP statistics class, where we were doing something called confidence intervals. Confidence intervals is not something we're really going to be focusing on in Prob Stat. It's more of an advanced AP thing. But how much of the globe is covered in water, would you say?
Say 85%.
The numbers vary, but it's anywhere between 65% and 80%, somewhere in that range. Most estimates have it about 71. So we ran a random simulation. We ran a simulation in the class where we're throwing the ball around. I can't do that today, but we're throwing the ball around. And if your pointer finger landed on water, then we said that trial was water, and we recorded it. And then if it landed on land, if your finger was on land, the pointer finger, then we count that as land. It was land or water, land or water, land or water. Well, we got 50%. We got 50-50. We're not wrong. That just so happens to be our simulation. Then we did the confidence interval. Now, the confidence interval has wiggle room, in which we were saying we were 95% confident that the true proportion of water on the planet is between this number and this number. Technically, we were wrong. We were wrong. But because I said 95% confident, it allowed for that little wiggle room in the middle to be wrong. In statistics, you will never be 100%. You'll never be 100%. Well, in the calculations, the 95% did have something to do with the calculations, but yeah. Now, I could be 99% confident, But, 99% confident is like, like this. There is one scenario in which I can be 100%.
Really?
You ready for this? I am 100% confident that the proportion of water on the planet is between 0 and 100%.
Fair enough.
But that statement is meaningless,
Exactly.
right?
That's so vast.
Yeah. But that's my point, though. With statistics, again, day one, confident statements with limited information. How confident can we be? How limited the information are we allowed to have? That's what statistics really is. Stay there. There we go. I got some definitions for you. I want to give you some definitions to kind of move forward, things that I may have verbally mentioned, but I just want to wrap up today with this. Definitions. What's this? Cool. First of all, let's talk about a population. You've heard the word population before. You have a general idea as to what population is. That's perfectly fine, perfectly acceptable. A population is an entire group that you're interested in. It's an entire group that you are interested in. For example, maybe my population is everybody in America. Maybe my population is just people who are going to vote. Maybe my population is just seniors at Barnegat High School. It depends on what it is that I'm interested in at the moment. But everybody within that group is in my population. Whereas a sample is a portion of that population. It's just a portion of that population. So I mentioned soup last week. I mentioned, imagine a giant pot of soup. Every single morsel of soup within that pot would be in the population. And then the sample that I would take would either be the spoonful or the bowlful that I took. That is the main difference between a sample and a population. And I'm going to have problems I'm going to throw at you at some point probably later this week or early next week that are going to kind of dive into those details. You'll see. Now, I may throw the word parameter at you. A parameter, whatever it may be, is describing a number from the population. For example, I could say, I'm going to make this up right now, like the average height of every adult male in America would be 5'10" or some junk like that. I don't know. I'm making that up. But if I say that the average height of every adult male or of all adult males in America is 5'10", then I could say that that is a population parameter, describing a number from the population. Whereas a statistic, and you can pretty much guess what this definition is going to be, it's describing a number from the sample. So if I took a sample of 100 adult males across America and then found the average height, I would only be able to call that a sample statistic, not a population parameter. Exactly. It is very difficult to know population parameters because you got to get everybody within that population. Unless the population is very small. For example, if I wanted to find the average height of all students in Mr. Markey's period 1B Prob Stat class cohort 2, that's just you two. I can easily get the population parameter. My population would be you, because that's the group that I'm interested in at the moment. Now, if I took a sample, maybe I'd get like one of you, which is like That's not really, it's a sample. It's a weird sample, but still it's technically a sample. But it's a portion of that population. You know, populations are not always 2 people. Populations are like thousands and thousands of people, typically speaking. Typically. But it depends on what you are interested in. Or what the problem is interested in, I should say. All right, last little bit of information. Actually, no, I do have to get that too. Okay, yeah, but this is the last page of information, and then we'll wrap up with this page. You all see this symbol? You know what it is? It's the 151st Pokemon. It's Pokemon number 151. You never heard of Mew?
Is that what it looks like?
No, it's not what he looks like.
Oh, geez.
It's what you call it. Oh, yeah.
I'm so confused.
This is the 151st Pokemon. That's Mew. This is the Greek letter Mu. Mu. That's the Greek letter Mu. What it is, and by the way, you can read it as Mu. You're going to see this. It's the population average. It is the population average. Whenever you see mu, if a problem has mu equals, they're talking about the population. Whereas this other one, we literally read this as X bar. We literally read it as X bar. You can pretty much take a guess as to what it is. If mu is the population average, what do you think X bar is? Sample average. Think about it. We ran 15 trials, didn't we? That was a sample. We took a sample. And in the calculator, it said X bar equals. It's the sample average. The notation that you use is very important. The notation. The notation, the notation, the notation. All right. Now, I promise, this actually is the last thing I got to write down. This absolutely is the last thing we got to write down. Unfortunately, because of COVID, class is going to be a bit more note heavy. Personally, I would have preferred to have been done by now, but since I'm only going to see you once a week, this is what we got. Let's talk about qualitative and quantitative. Qualitative versus quantitative. Qual has the root word quality. Quan, Q-U-A-N, has the root word quantity. Quantity versus quality. Quantity, Q-U-A-N-T. Say again?
The number of something?
Think about height or IQ or shoe size. You're absolutely right. Yes. There are numbers that are associated with quantitative. As you heard the root word was quantity, you're thinking numbers. Yes. There is such a thing as what we call quantitative data. And it makes sense. You can take an average. So, for example, if I got a bunch of people and I wrote down all their heights, I could take an average height. Absolutely. I can take an average IQ. I can take an average shoe size. It makes sense. Absolutely. Qualitative. Hold on.
Good morning, everyone, and please excuse the interruption. We are going to be doing a non-traditional fire drill.
Are you kidding me?
A non-traditional fire drill. So please allow me to explain. First, you will hear the fire alarm go off in just a few moments. When the fire alarm sounds, please do not do anything. Do not go anywhere. We are just testing the system. Teachers, we will ask that you keep students in their classrooms and explain to them where they would evacuate to should this be a real fire. Again, students instead, please do not leave the building. Please do not go outside the building. Simply, after the alarm is silenced, review with students what procedures you would follow if this was a drill. Thank you. Let's have a good drill.
Hey guys. The alarm's gonna go off. It's just a test. Just ignore it.
Where are we supposed to go out, Mr. Murphy? Don't we know? You don't know? We can fly away, right?
No. Here's the weird thing. In C-Wing, I'm technically like right in the middle of C-Wing. So we could, if we wanted to, we could go out that way, or we could go out that way.
Either way.
I like to go out that way because I could easily put my pen in the door. It's got like the double doors.
Yeah.
Actually, no, down here it does have that too. But I like this better. More sunlight. Whatever. Oh, we did it!
Again, that concludes our drill. Please teach
Good job!
the students what you would do if this were a real fire drill. Thank you.
We did it! Okay, back to this. Qualitative is also known as categorical. And qualitative would be like your favorite color or the town you grew up in or your favorite country. Here's the thing. If I had 100 students and I asked all of them, what's your favorite color? Does it make sense for me to average that answer together? Like, what's your favorite color?
No.
Red, and what's your favorite color?
Great.
Green. Okay, so it's fine. So like, you're red, you're green, I'm blue. Ready? You ready for this? Cool. That's great. That's data. That's definitely qualitative data. But if I took the average of red, green, and blue, does that describe anything about us? No, it describes nothing. The town you grew up in. I can't average the town you grew up in. I can't average your favorite country. It makes no sense. Qualitative is a quality that you can't average, or as they call it, categorical. Quantitative, as you said before, was quantity. They have to do with numbers mainly, and you can average them. That was a weird fire drill. I can't even imagine.
So if there's a real fire, what are you gonna stay in here?
No. If there actually is a real fire, like think about it. Like, that kind of that takes precedent over, locking in place or whatever, Anyway, that's all I got for today. Yeah, that was a weird class. Anyway, but I am going to be assigning stuff on Google Classroom. Make sure you're getting on that Google Classroom.
Yeah.
Get on that. Oh yeah, go ahead.
Oh.
There he is. Yeah, make sure you're getting on that Google Classroom because there's an assignment, and the assignment was the discussion that I am responding to your questions.
I'm gonna do it next class.
I got you. Yeah, I think I already responded to your questions. Yes, I did. Or not questions, but your answers or whatever. But yeah, we'll figure that out and stay tuned and we'll see what happens. All right. See ya live stream.
Doesn't look